Hi friends, welcome back to my YouTube channel. If you find this video is useful, please like, share, and subscribe. And click the bell icon for more updates. Today we are gonna know about describing motion from kinematics. Introduction of describing motion. Motion is the change with time of the position or orientation of a body. Everything in this universe is in a state of continuous movement, for example, the motion of animals and humans. Besides this, the basic particle of a matter, the atom, is also in a state of continuous motion too. Rest and motion. When do we say an object at rest or motion? It's simple, right? When an object is not moving, it is rest, and when it is moving, it is in motion. But in physics we have to define and describe. Rest: if the position of an object does not change as time passes, it is said to be at rest. Motion: if the position of an object changes as time passes, it is said to be in motion. Motion relative. Asterisk: motion is not absolute, it is relative. Position of a particle moving along a straight line. The position of a particle moving along a straight path line, described by a quantity x. The numerical values of x, together with the unit, gives the distance of the particle from the origin, and the sign of x denotes whether the particle is in positive direction or in the negative direction as seen from the origin. Distance traversed and displacement. When a particle goes from A to B, the total length of the path taken is the distance traversed by the particle, and the length of the straight line AB together with the direction of the line AB gives the displacement of the particle. Displacement in straight line. If a particle moves along a straight line, its displacement may be obtained from its initial position and its final position. The displacement is given by s equals x to x. The displacement of a particle moving in a straight line is the change in its position. If the particle moves from the position xt1 to the position xt2, then its displacement is xt2 minus xt1 over the time interval t1, t2. In particular, the position of a particle is its displacement from the origin. Scalar and vector. Scalar: a quantity that has only magnitude is called a scalar quantity. Example of scalars: mass, length, time, volume, density, etc. Vector: a quantity that has magnitude as well as direction and that follows the same rules of addition as displacements do is called vector quantity. Example: soft vectors: displacement, force, acceleration, etc. Speed of an object. The speed of an object that is moving is a quantity that tells us how fast it is moving. Average speed: the overall rapidity of an object in a given time travel of interval is divided by a quantity called average speed, which is defined as average speed equals distance traversed divided by time interval. The average speed of an object in a time interval is equal to the distance traversed divided the time interval. Speed: the speed of an object is the distance covered by it per unit time. Uniform and non-uniform speed. If an object covers equal distances in equal time intervals, however small the intervals be, it is said to have uniform speed. If an object does not cover equal distances in equal time intervals, its speed is called non-uniform speed. Speed equals distance divided by time. Distance equals speed multiplies time. Velocity. The velocity of an object is a quantity that gives the speed of the object as well as its direction of motion. The velocity of an object, the displacement, s, of the object in a short time interval divided by the time interval. Uniform velocity. If the velocity of an object does not change as time passes, it is said to move with a uniform velocity. Both its speed and direction remain constant. Difference between speed and velocity. Speed is scalar, while velocity is a vector. Speed does not have any direction. Velocity indicates the direction in which the object is moving. If velocity is given, we can calculate the speed. But speed is given, we can't calculate velocity. Because, whenever an object changes its direction of motion, its velocity changes. But its speed need not. Acceleration of an object moving along a straight line, dash. The rate at which the velocity of an object changes is called the acceleration of an object. Acceleration sad face final velocity minus initial velocity, divided by IME. A equals acceleration. V equals final velocity. U equals initial velocity. Units of acceleration, A, equals meters/seconds caret 2. Graph representation. A graph is very powerful method of presenting information. A graph is plotted to display the relation of quantities. One of the two quantities changes independently, and other quantity is depend on it. Equations for motion with uniform acceleration. See the given figure to understand the lines. The motion of a particle moving along straight line with a uniform acceleration can be described by equations. The points A and B on the graph corresponds to the times O and T respectively. The velocity of a particle at time t equals 0 is u. In the graph, OA represents u. The velocity of particle at a time t equals 0 is u. In the graph, OA represents u. The velocity if the particle at time t is VOD represents v. Drop the perpendicular b on the axis. Also, drop the perpendicular AC on b. Velocity, time equation. The slope of the velocity time graph gives the acceleration of a particle moving in a straight line. From the figure, for the line AB, slope equals BC divided by AC. Therefore from figure, we can describe the equation of velocity time. Final velocity equals initial velocity, plus acceleration multiplies time. Displacement, time equation. S equals area, OABE, from the above figure, the area under the velocity, time graph is equal to the displacement. In the time interval OT, the displacement equal to the area OABE. Displacement equals area of rectangle OACE plus area of triangle ABC. Displacement equals initial velocity multiplies time plus 1 divided by 2 multiplies acceleration multiplies time square. Velocity displacement equation. From the above figure, the area of trapezium equals 1/2, sum of all parallel sides, asterisk, distance between them. Area of trapezium OABE. Final velocity square equals initial velocity square plus 2 multiplies acceleration multiplies time. Average velocity of uniformly accelerated motion. Consider a particle moving along a straight line with a uniform acceleration. The average velocity of the particle during time OT is average velocity equals initial velocity plus final velocity minus initial velocity, divided by 2, from the given above graph. Circular motion. A particle moving along a circular path changes its direction continuously. Its velocity is not constant even if speed is constant. V equals 2 multiplies pi multiplies r divided by t equals 2 multiplies pi multiplies r divided by v, r equals radius of a circles. T equals time. V equals speed. 2 pi r equals length covered. Thank you for watching the video. If you like the video, don't forget to subscribe. Goodbye until the next time.